So the objective of this presentation is to introduce and give you a good sense on what is and how to use the database of scenarios that has been assembled to support the latest Working Group 3 IPCC report. To do that, we'll have, and this is the first, of a series of regional workshop that is organized by the IPCC TG Data Group, and with others coming in for different regions in the coming weeks. So to do that, we have 2 hours overall, which we will divide into three main parts. First, we'll provide us with Volker and I will provide a global introduction to the use of scenarios in the IPCC AR6. Then there will be a presentation on TG data, the principles for use of the data, also on the Data Distribution Center by Alab, so David Ewart and Adam Millward. And then and all that will be about 40 minutes. And then we'll go deep into the AR6 Scenario Database itself, and Ed will be the main presenter here. As you can see, we have tried and put a lot of time for questions and answers within each session, but also in the end, we'll try to leave the last 30 minutes for yet another round of questions, so that really this session be as interactive as possible, and that you get out with a good sense of really how to use, how to access and use this data. Given the number we are, closing into 200 people around this virtual table, we will unfortunately not be able to have questions asked orally. So we propose that you use the Q&A feature. There's a button on your screen, so that you can type questions, and then we'll try and answer them orally. We also try as much as possible for the questions we are not able to answer, we don't have time to answer orally. We'll try and put some answers directly into in writing. Also, please keep your mics closed, obviously, given the number of people. Voila, with no further ado, let me start and try and give you a quick overview of how models and scenarios have been used in the IPCC AR6. First, this first slide shows you the structure of the report on the right-hand side with 17 chapters, and I will be mentioning quite a lot Chapter 3, long-term mitigation goals and pathways, which uses a lot of the long-term mitigation scenarios. Chapter 4, mitigation and development pathways in the near and mid-term, which uses a lot of national and regional scenarios. And also, I'll be talking about the sectoral chapters, chapter 5 to 12, that will make use a lot uses sectoral scenarios. One message that you will hear throughout is also beyond the scenarios themselves. Do not hesitate to read the full report. There's a lot of material in there that is still very relevant. It's been published less than a year ago, and there's a lot of material that is not obviously in the summary for policymaker or even in the technical summary. But do not hesitate to dive into the full report. There are a lot of signposts to help you find the information that you're looking for. So, just to start about scenarios in AR6, maybe it's good to go back to AR5, the fifth assessment report, which was criticized for overemphasizing the use of scenarios, and notably global scenarios, at least relative to other lines of evidence. That was not so much in the full report, but more in the summary for policymaker and in the subsequent communication. So the idea from the onset was to have a more maybe balanced approach in AR6. First of all, we have not one but two chapters dedicated to mitigation scenarios. One, as I said, chapter 3 on the long term, and chapter 4 more on the short and medium term. This is a temporal divide, but it's also a divide in terms of global scenarios have been used in chapter 3, and national scenarios mostly in chapter 4. Scenarios and illustrative scenarios remain extremely important and critical when you discuss the mitigation pathways to try and illustrate the different options we have in front of us, but they are less prominent in the overall narrative. And last but not least, there's been really an extended effort to really open the box. What are the models that produce these scenarios? What are these scenarios about? How are they constructed? And there's a full annex that is dedicated to this, which I really encourage you to have a look at. So scenarios in AR6 basically come from, can be grouped into three big pots. First, the best known are scenarios that are economy-wide, so and that cover all countries in the world, so that are global scenarios produced by integrated assessment models, mostly used in chapter 3, of course, in many other places in the report, but that's really the home base is chapter 3 in the report. Then you have also scenarios that are still economy-wide, but that have a much narrower geographical scope, regional or national. And those are mostly used in chapter 4, again in many other chapters, but in chapter 4. And finally, you have sectoral models, typically global, such global transport model or global land use models that are used in specific sectoral chapters. So what I'm going to do is to explain a bit how each of these groups have been used in the report. Global models and scenarios come from a well-organized research community, which has a long history of working together and which is all structured around the Integrated Assessment Modeling Consortium, IAMC. And so it was not actually the first time in AR6 that IIASA and IIAMC did a call for scenarios to support the assessment, the sixth assessment report. As a result of this call, more than 2,000 scenarios were collected, and about more than 1,600 remained after the first selection, representing basically a quasi-exhaustive coverage of the existing literature. And this is really great because when you have a quasi-exhaustive coverage of your literature to do an assessment, you can do both quantitative, but also qualitative, but also quantitative analysis. And a lot of, and chapter 3 there's a lot of analysis of this material in the chapter. The two charts on the right-hand side try to illustrate that material, the amount of effort that has gone already into analyzing this data. The idea is not so much to explain in detail what is in the charts, but just to point out that they exist. Please note that the figures, the figure on the bottom is actually figure 3.36, meaning that there are 35 figures beforehand that look and analyze different aspects of this data. The picture is quite different for national models and scenarios. The reason is that you have a much broader research community that produce many more centers, research groups that do produce national scenarios. Of course, there are 200 countries in the world. And that research community is much less structured. There's no IIMC for national modelers. Still, we tried for the AR6 to have we launched a call for national scenarios with IIASA, the Energy Research Center in Cape Town, which yielded more than 500 scenarios from nearly 50 different models. So that's significant. Yet it's only a mixed success in the sense that we only cover that data only cover a fraction of the existing literature that we know, with quite an unequal country distribution. Of course, and as the slide on the left hand, the graph, sorry, on the left hand side illustrates, we already know that anyway, there's a lot of differences across countries as to how many modeling teams they have and how many scenarios they have already produced. And roughly, there's a correlation between the number of scenarios and the size of the emissions of a particular country. But that database currently is not even representative of that distribution. Still, that effort was, I think, really worthwhile doing, with a lot of lessons learned, notably for the next and subsequent assessment report. So we still use that data in the report, mostly in qualitative or illustrative ways rather than quantitative, except for some specific topics, and Volker will come back to it. The two important points for this audience: for global assessment, it's important to have. It's difficult to have one chapter for each country. So comparative cross-country studies based on national models are really important. And the more we get, the more material can get into future assessment reports. Second, and maybe even more importantly, we realize that a lot of the policy relevant scenarios at national level are not in the database, not because people refuse or we did not reach out to the right people, but just because those scenarios are not published. For instance, in France, the French national mitigation strategy has never been published. So it's material that is not in the database, yet it is the most policy relevant scenario in the country. And there are others that have been also in the public debate that are not being discussed, and that gap is really an issue for the relevance of the assessment. Quick word about the national models and the sectoral models and scenarios. Sorry, they have been used much more parsimoniously and in a way that is much less organized. So you have bits and pieces in different sectoral chapters. To conclude, let me just mention again the annex on scenario and modeling methods, which I really again encourage you to have a look at, because that's really there's really a lot of information that has gone in there to explain and open the boxes. With this, I will stop. Thank you very much, and leave the floor to Volker to dig more into the use of national scenarios. Volker, you have the floor.
Thank you, Frank. And yeah, let me also welcome everybody in this webinar. Very happy to see that there seems to be quite a bit of interest. I hope my screen is visible now. Yeah, as mentioned by Frank, I'll talk a little bit more about a few selected cases of the use of national and regional pathway information in the sixth assessment report. This is also analysis that has, or assessment work that has also gone mostly into chapter 4. I also would like to encourage the audience to start posting questions, because we will have the possibility to basically react to that in a short Q&A session after this presentation. But let me continue here. I guess most of you will have seen this figure, which is one of the figures in the summary for policymakers of the Working Group 3 report. It doesn't show regional or national level information, but globally aggregate information. However, in the underlying chapters, there has been basically a vetting or a validation process, if you wish, of this global level assessment, where possible, using the regional and national data and studies that basically went a bit deeper into this material. And this is specifically true for the policy assessment for 2030. As you see, this figure basically puts long-term temperature pathways into the context of short-term policy goals, most notably the nationally determined contributions, or NDCs. And one of the outcomes when putting these two streams of literature together here is that 1.5 degrees is basically, with the current ambition as articulated in the NDCs, very likely not to be achievable without ratcheting up until 2030. Even the 2-degree target, to reach a 2-degree target challenge is increasing considerably due to also putting more pressure on future generations to decarbonize the system much more rapidly. And even the self-determined ambitions as articulated in the NDCs, there is an implementation gap in terms of policies on the ground that basically enable this short-term transition. But let me now go from this global level picture. There's a complementary table in the SPM that basically summarizes the global quantitative information in terms of emissions outcomes for 2030, the implementation gap and the emissions gap towards 2 and 1.5 degrees. But this information is actually coming out of chapter 3 and 4. Chapter 4 here contributes specifically an assessment of studies that have looked into where NDCs as well as current policies will basically get us in terms of emissions outcomes by 2030. And that in itself is grounded in a much broader literature review and assessment of studies that have looked not only at those outcomes globally, but also at the regional and country level. And here we've basically used national and regional level studies to compare with outcomes for larger regions as depicted in globally comprehensive studies, to see whether there is in principle alignment, or whether there is and therefore strengthening basically the lines of evidence, or whether there is disagreement. Let me therefore dive a little bit deeper into this table. This is table 4.1 in chapter 4. This is just a selection, mostly basically showing here the global results, the five largest emitters, some of which come from Europe, and a selection of European countries for which there is data available in the Scenarios database that through the process that Frank just summarized. Let me use the EU as an example here, and for instance highlight the current policies projections. Here we basically see that the median coming out of the EU region from globally comprehensive studies and national, or in this case regional studies, basically being in pretty good agreement in terms of the outcomes. And that of course then increases confidence in that the globally comprehensive studies, the results of which are summarized above, are actually doing a decent job also at the national and regional level, to the degree those are explicitly represented. And here's another outcome for another metric, Kyoto greenhouse gases as compared to fossil CO2 emissions before, where we also see a relatively good alignment. Let me also emphasize and come back to one point made by Frank earlier. We have collected below the EU level also pathways. This is partly national level information from global pathways and partly national level studies. However, here the situation becomes much patchier, and I think this is really where additional effort can be made or would be useful. And on the other hand, improving basically the coverage of studies here for allowing further quantitative evaluation would be helpful. This may not be doable by lead authors in the next assessment report by themselves, but would basically require community coordination, research community coordination, to basically bring this information together and allow then this to be taken up more comprehensively by authors of the upcoming or the next assessment report. To wrap up, I just wanted to show a couple of other examples. This is not necessarily information from national or regional pathways, but regional scale information that was assessed, coming from partly from global assessments, but basically breaking down here the regional mitigation costs by 2050 across different regions. Let me pick here the European perspective, or point out the European perspective. The aggregated costs of mitigation in Europe are comparatively smaller compared to other regions, and also compared to the global average, expressed here as percentage losses of GDP. It is important to take into account that this is these costs reflect basically a cost-effective allocation of mitigation and do not consider any financial transfers or equity considerations. If those would be taken into account, implied financial transfers by the middle of the century would be in the order of several $100 billion per year, to which Europe would need to contribute. And then another point from this more regional and national, from this more regional analysis, is that delayed action, as elsewhere, would also in Europe increase costs compared to immediate action. So pushing off doesn't pay off in Europe or other regions. Last point is, or last example is information on investment needs towards a 2-degree transformation here. And let me also pick out European scale results. So globally, we would basically require an upscaling of investments over the next decade, or not over the next decade, is compared to by 2030 compared to 2020. 3 years have already passed, by a factor of 3 to 6. To be on track with the 2-degree target. For Europe, this gap would be a bit smaller, but still requiring an upscaling of a factor by a factor of 2 to 3 by 2030 in terms of investments going into a low carbon transformation. And with that, let me leave it at that and pass back to Frank for the Q&A question, for the Q&A session.
Thank you very much. I see Volker for this presentation. I see that we have already we have some questions on the Q&A thing, and thank you very much for the participants for posting them in. Some have already been responded in writing. Maybe I'll address Nada's question, and Volker, if you can take on Gabrielle's. As for Sandra's question on 1.5, that at least for me it's away from my own expertise, so I can't really respond. I can't really respond. So on Nada's question was to see to ask whether it was easier to publish national and relevant policy relevant scenarios, or to include them into a non-published scenario group batch of scenarios. My sense would be the former, so it would be preferable as much as possible to have these scenarios published. So encourage the public agencies to do so. Often they come from, they're actually based on models, and they are built based on quite a rigorous process. So I do think they would fit within the, they would pass on peer review and could be published as well as others. And that also would help make clear some of the underlying assumptions, and so make comparability easier with the others. So that's a preference. However, it is also understandable that in many public agencies that produce these scenarios, publication itself is not an objective. Might be considered even waste of time, and so that requires an effort by the producers of these scenarios. But I think that's a conversation we should be where the IPCC should be having with governments, because there are, so many of these policy relevant scenarios out there. Thank you. Volker, can you say a word about Gabrielle's questions?
Yes, happy to take that on. Just to repeat, Gabrielle's asking whether the mitigation costs include DALYs. So I assume that's disability adjusted life years. So basically impacts or avoided impacts, that's my interpretation of the question. I mean, yeah, I didn't go really into the definitions here. Actually, the costs here, and you will recall the figures had a GDP loss, it really just refer to costs, but do not take into account the benefits, either direct benefits through reduced climate impacts or co-benefits that may emerge from, for instance, reducing air pollution and therefore reducing also health impacts. Those are not included. So it's a strict cost calculation without taking into account the benefits. I mean, there is efforts in the literature bringing those estimates closer together. Unfortunately, we are still not fully there, bringing this at the more granular level, bringing the costs and the benefits of the of decarbonization strategies fully together.
Okay, I see many questions coming in, and we will be in a position where we cannot answer all of them, and at least at this time, unfortunately. What I propose is just to give a quick point on Ole Christian's question on the role of how governments can use this information, because I think it's really relevant for the discussion, and then move on to the next presentation. I think that quite a lot of potential use of this material. First, the global scenarios, at least, they provide, even at the national level, they provide an environment, or at least they provide a sense of what the environment may look like, depending on how the global community decides to reduce its emissions, with a lot of relevant information on, say, global energy prices, on global trade, so the environment within which a country must make its decisions. That's one. And then, depending on the literature on scenarios within the country, obviously, they will dig much deeper into the specific policies, the particularities or national circumstances that are important. And so those scenarios may also help inform policy debates, not necessarily by saying, oh, this is what you should be doing, but rather by saying, oh, if you providing what if, or trying to provide what ifs, in terms of, okay, if we put in place this or that policy, here are some of the potential consequences that might be there. So if you are lucky enough to have already mitigation scenarios that have been developed within that country, they can certainly already help support the policy debates. With this, I think we need, unfortunately, to move on, and I give now the floor to the video on the TG Data Group.
Hi, my name is WR. I co-chair with Sebastian Vicuña the IPCC Task Group on Data Support for Climate Change Assessments, TG Data. And our objective is to improve access to IPCC data, both for IPCC authors and also for scientists who rely on the IPCC reports. So this presentation is just meant to give you an overview of the efforts that we made in AR6 to make IPCC data more accessible and reusable, And the work relies heavily on the IPCC data distribution centers, so the DDC, and the technical support units from all three working groups. So I'll just be introducing TG data briefly, and then Adam will present the DDC and its data curation activities, followed by Ala, with the role played by the working group 3 TSU. So the task group on data support for climate change assessments was created in 2019, and it takes over from the previous task group on data and scenario support for impact and climate analysis. So this previous group was created in 1997 to provide regional climate change information, and it published various guidelines on socioeconomic scenarios, greenhouse gas scenarios, sea level scenarios, and also statistical downscaling. Now, TG data is focused less on creating these types of guidance material and more on data access and reusability. And so our mandate
is really about putting data out there. So our objective is to make sure that the IPCC data follows the FAIR principles, meaning data should be findable, accessible, interoperable, and usable, reusable. This applies both to the data assessed by authors as to the data created by authors to prepare graphics and tables within the report. And so to achieve this, we've been working with the DDC, a network of institutions that generously contribute their expertise in data creation to the IPCC. And one of the reasons why we want to do this is that there's an enormous amount of work that goes into the report and its review. Just to give you an example, in AR6, over 180,000 comments were collected for the first and second drafts of the three working groups. And each and every one of these comments was given a response. So really the data that analyze all of this deserves to be highlighted and made available so it can be used as a starting point for further research and analysis. So our main objective for the sixth cycle is to publish and archive the data underlying figures and tables found in the summary for policymakers and the technical summaries for all three working groups, as well as the synthesis report. And so the DDC is also working to preserve a snapshot of the core CMIP6 and Cordex data used by IPCC authors in the assessment, this emission scenario database, as well as other key biophysical and socioeconomic data sets that are assessed. And so archiving and publishing those data sets requires an enormous amount of work and coordination distributed among AR6 authors themselves, the technical support staff, and the data distribution centers. And so now I'll let Adam present the DDC and its data curation activities. Thanks.
Hello everyone, my name is Ala Kurdaji and I'm Senior Scientist at Working Group 3 Technical Support Unit. Today I'll be describing to you the role of the TSU in supporting the TG data process and the use of data in our underlying report. The TSU is overseen by the Working Group Bureau and works closely with the TG data group in order to ensure the implementation of the FAIR data principles. As you well know, in addition to undertaking the assessment, our authors also produce data and figures to support the assessment. And to give you an idea, in Working Group 3 AR6 report, we have around 320 figures. The role of the technical support unit is to provide guidance and training to the authors, as well as figure and data management. And we are also in the process of produce a GitHub repository that include the underlying data of our SPM and technical summary figures and some of their input data. We also work closely with our colleagues at the Data Distribution Center who set up a Zenodo AR6 community, and we provided them with the underlying data for some of our SPM and TS figure as well as their input data. We work closely with the Secretariat in order to ensure that all queries related to figure use are addressed. We work with the data distribution centers in order to ensure the quality control of the implementation of the FAIR data principle in our report. Just a reminder to everyone that the IPCC does not produce its own data, but rather reproduce data available in figures or post-processed data from existing data sets available in the underlying literature. One of the major data products for the Working Group 3 AR6 report is the AR6 Scenario Explorer. and Database, which is hosted at the International Institute for Applied System Analysis in Austria. So the FAIR data principles are there to ensure that the assessed data code or analyses used to produce figures and tables in our report are properly documented and curated to allow traceability and stability, as well as transparency of the assessment. These principles also support the implementation of the IPCC error protocol, which is used should an error be found at a later stage. As for the implementation of these principles in the Working Group 3 AR6 report, they have been implemented on all summary for policymaker figures. They have also been implemented on the technical summary figures and some of the input data sets for these figures. You can find all archived data for the AR6 assessment in the AR6 data catalog, which I provide the link for here. As for Working Group 3, SPM and technical summary data and figures, they can be found available in the Metadata Works Data Distribution Center catalog, which I provide the link for here as well. And for each of these figures, we do not only provide the data, but also the metadata, the abstract and citation, as well as information on the derivation of the underlying data and the recommended figure citation. And as I mentioned earlier, we worked closely with our colleagues in the DDC on the providing data for the Zenodo AR6 community. In terms of licensing, IPCC post-processed data and figure data are distributed under a Creative Commons Attribution license, as long as this does not infringe the interest of relevant license holders. We made this recommendation in order to facilitate the reuse of the data both in research by practitioners, the media, and users more broadly. In terms of copyrights, the IPCC assessment product, be it text, logos, maps, or electronic downloads, is a property of the IPCC, are protected by intellectual property laws. You may download, copy material for personal and non-commercial use. A limited number of the figures or short excerpt of the report can be reproduced for books, for instance, and there is no charge for this use as long as the original source is properly acknowledged with full citation, be it the chapter or the SPM, and full legend. Any queries regarding reproducing IPCC material can be submitted to the IPCC Secretariat. So to summarize, the AR6 established TG data in order to strengthen the collaboration between the DDC and the TSU on the implementation of the FAIR data principle for the first time in the IPCC. Now that we are in the last few months of the AR6 assessment cycle, TG data will be debriefing on the experience in the AR6 with the DDC, TSU, as well as authors to provide recommendation for future cycle. And this is a key step for the implementation of the FAIR principles immediately at the start of the next assessment cycle with a strong collaboration across all parties, as well as establishing a direct link between contacts in the TSU, DDC, and TG data from the start. Thank you.
Well, thank you very much for this presentation. So we
Frank, there's one last
oh, sorry
video. Sorry.
Governments, journalists, and citizen groups all need access to credible, relevant data on the causes, impacts, and effective mitigation strategies for climate change. Enormous amount of data is generated for climate change research, and it's an incredibly valuable asset. So distributing and preserving that data ensures the full value of the data is maximised, and that's what the DDC is all about. In terms of our history, well, we know that trust, openness, and transparency are fundamental tenets of the IPCC activities. So the DDC was established in 1997 to ensure the provenance and traceability of all of that data and to ensure it would be high quality and accessible to researchers across the world. They've also been established to support the provision of data and to provide tools and guidance for all the IPCC authors, editors and coordinators during each assessment cycle. In terms of our principles, we sign up to the FAIR data principles. So it's all about findable, accessible, interoperable and reusable data. And I'd encourage you to come and read some of the documentation we've got around that. We also sign up to the trust principles around data preservation within data environments. We sign up to DataCite's principles around digital object identifiers and archival. So what does that look like in the real world? Well, it's all about traceability, credit and preservation. So if we're looking at one of the assessment reports at the moment, let's say the summary for policymakers for working group 3, there'll be a number of different graphics. And let's say that figure SPM4, which is all about global GHG emissions, was interesting and we wanted to dive into a little bit more detail. We can then transfer over to the IPCC data catalogue and we can go and explore the data itself that supports those final figures. So there's 4 different panels, there's 4 different data sets. We can go and download them, explore them and understand the context of that data. That final figure data is an analysis of other data, other source data. And so that final figure data references those different sources. So the catalogue also then provides the traceability and credit for those different sources, such as the IIASA data or the Copernicus data as well. And all of this ensures that the data is preserved effectively so that it conforms to the principles of fairness, findable, accessibility, interoperability, and reusability. In addition to providing the data catalogue and all of those preservation services, the DDC offers a support desk for the public so they can come and ask questions, and there's an interface to the DDC team, and they can also interface with authors and editors and coordinators through that platform. We've got a really good customer satisfaction rating through that capability. We also provide a metadata onboarding platform within the data catalogue. So this is a secure area where coordinators can come in and tell us about all of the data that's coming through the assessment reports. And we've got a metadata profile that describes exactly the type of information we would like to capture when we're preserving, we're archiving data to make it more findable through the data catalogue. If you're interested in that, I've put some links in the resources slide at the end of this presentation. In terms of the opportunities going forward, well, we think there's an opportunity to support increased data access and usage through the platform and through the services we offer. We want to fill in the gaps in some of the IPCC data archival processes. We think we can improve the quality and efficiency of data management for the whole IPCC and provide leadership and best practice, such as the metadata profile that we've published on GitHub. We're also looking to enhance some of the catalogue features. So we're going to be creating collections to bring all of the different data sets together. We want to create a bit more of a dynamic user interface where we can preview some of the content and also create a space where events can be published. So if someone's created a webinar like this to talk about the data, that can be displayed alongside the data itself and be available to different type of consumers. We're also looking to enhance the service, so increase the coverage of input and intermediate data sets during the next assessment cycle. We're looking to develop some user-friendly visual overviews that describes the relationship between data sets and organizations across the IPCC. And also we're going to look at establishing federation that will allow different data repositories to talk to one another and start to share the metadata to improve visibility and accessibility of the data across the IPCC. So in terms of the resources, I'd encourage you to come and look at IPCC data and search for data sets. We've got some schemas on GitHub if you're interested in metadata profiles, and also if you'd like to learn more about us, please follow the links below. Thank you very much for listening.
Yeah, this time this time was the right one. So thank you very much for the video and presentation. I see that the Q&A session is nearly just one question left, but will allow me to just clarify maybe that really the focus of this particular webinar and session is on the database of scenarios that have been used for the working group 3 So for mitigation scenarios, so we're talking about mitigation scenarios, so mostly socioeconomic scenarios, but really climate scenarios themselves produced by Working Group 1 of the IPCC. That's a whole different universe of scenarios, and that is not the focus of the webinar. The webinar today. I'll let Ala and Nada put in the chat if there are similar webinars for the use of really climate scenarios per se. Without further further ado, I think it's now time to switch to really the core of the discussion, that is the presentation of the AR6 database scenarios. To do that, we will change chair, and I'll invite Volker to take the lead from now on. Volker, please.
Yeah, thank you, Frank. Let me maybe pick up one of the points you just made, and I mean, to more clearly distinguish the data products coming out of Working Group 1, so the climate assessments out of CMIP and other exercises, and the socioeconomic and emissions scenario data that have been used in Working Group 3. I think Ed's demonstration will make this very clear. What the difference is. Also noting here that TG Data has previously organized webinars on the interactive atlas for interactive display. A similar job is what the Scenario Explorer that Ed is now going to introduce does, basically, for the Working Group 3 emissions pathway data. In case there are further questions on the data sets coming up, we can also handle them in the final Q&A session. So let us move now over to Ed's presentation. We will first start with a 3-minute introductory video on the Scenario Explorer, and then we'll move into the live demo afterwards. So Ed, the floor is yours.
Thanks, Volker. Just need to find the option that we share the sound. Okay.
Hi.
Could you hear that? Okay.
I'm Edward Byers, and this is a video pill about the AR6 Scenario Explorer and Database hosted by IIASA. In April 2022, the Working Group 3 of the Intergovernmental Panel on Climate Change was approved and released. The Working Group 3 report maps out the options and pathways for mitigating climate change, concluding that nothing short of full societal transformation is needed, starting immediately, to have a chance of limiting warming to 1.5 degrees. We saw statements like these in the headlines, numbers about emissions reductions by 2030 and fossil fuel phase out. Many of these numbers from the report come from the AR6 Scenarios Database. For over 3 years, more than 3,000 quantitative scenarios were uploaded by the energy and climate change research communities from around the world, many of which members of the Integrated Assessment Modeling Consortium. Analysis in the latest IPCC report is supported by this data, which contains short and long-term projections on CO2 and greenhouse gas emissions, global temperature levels, the energy sector, socioeconomic development, industry, buildings, transport, and land use. This has been the largest and most inclusive scenario collection process in Working Group 3 to date. To access AR6 Scenario Explorer and Database, simply search AR6 Scenario Explorer or visit data.ece.iasa.at/AR6. Access the database as a guest. Otherwise, register for an account or sign in to be able to save your analysis of workspaces within the Scenario Explorer. You can load existing workspaces, such as these ones made for illustrative mitigation pathways, or create your own, customizing your panels to show different variables and scenarios. You can download the data for your own analysis and check out the PyM Python package designed specifically for this type of dataset and analysis. Want to compare scenarios that limit warming to 1.5 and 2 degrees? The database filters make this possible to easily change the scenarios, variables, and regions that are displayed. There are also options to change visualization settings, export images, download the data. Documentation can be viewed directly in the panel or on the documentation page. On the downloads page, you can download full snapshots of the database as CSV files for analysis, split by different regional aggregations such as global data and by country. Downloads also include metadata indicators, which adds additional information about each scenario in the database. For tutorials on how to use Scenario Explorer in more advanced ways, information about database and process, citation, licensing, and acknowledgements, see the About page, or get in touch with us. This community effort has supported analysis of Working Group 3 assessment, but will continue to support research on mitigation of climate change for years to come. If you're using database for your own research and need help, have questions or feedback, we would love to hear from you.
Okay, so that was the short version, advertisement, I guess. And now move on to the demonstration. So good afternoon, everyone. Good morning to some of you, and welcome to this demonstration of AR6 Scenario Explorer, and great to see all this interest. So we'd originally planned to make this session a little bit more interactive, but with the numbers of people logging on, this may cause some issues if everyone's trying at the same time. So please don't all log on now. We are recording the session. We're going to provide also detailed instructions in the email afterwards and put it on the website. In the session, I want to demonstrate a number of features showing examples specifically with European data, including the registration, about how to use the workspaces, customization of the data panels, selection of scenarios and variables, and then also about the documentation. And so as you can see on the screen, this is the landing page. You can log in as a guest, but there are benefits to registering, and the registering is fairly simple. We don't collect much information. And as I said, you can access also multiple scenario explorers. So for example, the 1.5 degrees report and the network for greening the financial system, which are the scenarios used by the central banks and finance sector. You can save the workspaces for use later, and you can also share workspaces when you have a registered account. And you have access to downloads, which are not always available to guest users. And so this is the landing page once you do log in as a guest or registered, and you see this is what we call workspaces. Workspace is a customizable dashboard developed by a user comprising different data panels. You can develop multiple workspaces and save those configurations, export the data, and share those workspaces with other users. We can see here, as I mentioned, the 4 workspaces made for the illustrative mitigation pathways. These were 9 high-quality scenarios chosen in the Working Group 3 reports and are highlighted due to their interesting, often common, but also differentiated characteristics. And so, for example, there's one on very low demands and high efficiency, another with very high renewables, another with net negative emissions, and they're really worth exploring. In these workspaces, they're shown primarily for global data, but there is also regional data available. And these IMPs are introduced in the SPM box on scenarios and also in Chapter 3 in more detail. We also have 2 workspaces created specifically for the session, so Europe 1.5C pathways and the model comparison for these JRC times and Reminds EU models. So to open a workspace, there is an open button. I've got it loaded already. It can take a little bit of time to load the data. And this example compares key variables from what we call the C1 or the 1.5 degree pathways, specifically for the European region. And so these are pathways that have come from global integrated assessment models. The benefit of them is that they're globally consistent, they're cost optimal pathways, they cover energy and land use system emissions. And we know that on the global level, this pathway reaches 1.5 degrees with no or low overshoot, limited overshoot. Limitations are that these global pathways might lack some detail compared to specifically national or regional scenarios. This is what we would call a multi-model or multi-scenario comparison. It's useful for understanding a range of possible outcomes of these scenarios that consistently reach 1.5 degrees. The models don't always agree on all aspects, and that's not necessarily a bad thing. Diversity of outcomes can also lead to useful insights. Here we can see 4 graphs. They each have a title at the top, which is basically the variable name, and each one has 97 scenarios. So we know that in chapter 3 of the report, 1,202 scenarios were run through the climate assessment models from integrated assessment models, and they were classified according to their climate outcomes by the peak temperature and end of century temperature. And this 97 are the most ambitious mitigation scenarios that limit warming to 1.5 degrees with a 50% chance with no or limited overshoot. We've got the panels configured for energy industrial process CO2 emissions, methane from the FOLU sector, carbon sequestration, and also electricity supply. We can see, for example, consistent reduction in the energy industrial process emissions towards 2050. We can see a range of, let's say, projections in the level of CCS used within Europe, some with low or no CCS and others with quite high levels. We see generally growing supply of electricity through to the end of the century. And concurrently, we can also see the emissions CO2 from the electricity supply sector are dropping rapidly by 2030s to the 2050s. A lot of those scenarios are net negative by the end of the century. And also we can see here in the methane FOLU emissions, also a range, but also less lines on the graph. So this is an important point to make now, is that not all scenarios have reported all variables in the database. We have, as I said, over 3,000 scenarios from a range of global, multi-regional, sectoral, and national models. It's the first time in the scenarios assessment that we've tried to include data from models that aren't just the IAM type. So whilst many of them are from IAMs, there were approximately 100 models that had never participated in the IPCC process before, and about a 5 times increase in the number of models compared to the 1.5 degrees report. Many of those models are national, and that was great news, work led by Volker and Frank and Harold, and they have different focuses also. And so with all these different models, many of them report different variables, different data types. And so we don't have 100% consistency in what's available for different models and scenarios. And that's why we have slightly less scenarios. We have the same number of scenarios, but not all of them are reporting methane specifically for the FOLU sector. In terms of customizing these panels, so I'll work on this top left panel. We can change the region, for example. We click on region, this opens a drop-down box. And here we see the different regions that are available within the database. The global region, we've got what we call different regional aggregations. So there's a 10 region split, a 5 and a 6 region split. So we're currently using the 10 region. And then we've got the countries. There isn't data available for every country, but this was possible. And hopefully in future years, we would have that. It depends on the scenarios that have been submitted. But we can quickly change to North America here. We click apply, and this updates a quick query, and it brings in the information from North America for the same variable and the same scenarios. In order to change the variable or the data that's being showed, we can click on here, one variable or the data selection panel. This is a little bit more complicated, or there are different options. So there's this drop-down box, and this gives us some insight into the structure of the variable tree. So we have these kind of main categories, there's many of them, and they break down into a sort of a nested list. So if we click on emissions, we can see then different categories of greenhouse gases and types of emissions. And for example, for CO2, then we have breakdown by different sectors, the sources of the CO2. And so it's this kind of nested layer in the way that the variables are structured. We can search for a variable of interest by typing in the box here. So let's say we put in price. I'll click here and change it to carbon price. Remove the other one. We can show multiple variables at the same time. Click apply, and now we have the projections of the carbon price. The other options for selecting the variables, we have these filters here. And so clicking on socioeconomics gives us these options, energy, some of the key energy variables, emissions, it gives us a shortcut to the emissions, and then the climate assessment. These are the results that were run from the simple climate models. And one thing that is also useful for finding data is this button that says show only available variables from the scenario selection. So this will reduce the amount of information that you see and only show you what's available depending on the scenarios that we have. If we see on climate assessment, there aren't any data available, but that's because we're still on the region of North America. If we change this to the globe, because I know that this data is only available for the world, then we can see that this data is now available for the world region for these 97 scenarios. And we're going to select this temperature profile. And now we can see these projections of the global mean temperature that are approaching 1.5 degrees, a little bit of overshoot. We can see this only goes to 2050. So we can click on ranges here and extend that to 2100. And now we have the full century temperature projection. A little bit of overshoot for some of them in 1.5 degrees, but all of them below 1.5 degrees by end of century. We can also change this at the end, change the title here. I'll just update that quickly. So those are some of the main features in terms of changing variables and regions and how variable selection can be made. In terms of visualization, so this is the button that we can view the legend. This is a line chart. We can change it to a bar chart. It won't make sense now, but I'll do it later. Another useful option is this button here for viewing the data in a table format. And here we can get a nice idea of which of the models and scenarios that are included, what's the real variable name, and also look at the data. And we could sort this column at the end to see, well, which are the warmest scenarios in the selection. Some of them going up to 1.49 degrees. That's perfect. And that's the warmest scenario in the selection. Just over here is the download button. You can download to CSV or Excel file, and this will download only the data that we've selected for this panel. Later, we'll introduce the large downloads. You can download all the data from the database, but these are large files to work with. It's not always convenient. If we just want to extract a small snippet of data, we can build a panel quickly with just the scenarios and the variables that we want. Click the download button, and we get just that selection available here. Lastly, these options here, we can maximize the panel to make it widescreen. We can add another time series panel, so this will add one again to the right. We can remove it. And then the clone panel function is also a useful feature. So it can take a little bit of time to configure these panels. And if we clone a panel, it will duplicate it. And then we can just change one of the things. So one that we did earlier, we've got the GDP projections here. I cloned it. It replicated exactly here. And then I'm going to just change the variable to population, and it will have exactly the same settings. It's still got the same title, but everything else is the same. And so this is great for building up a workspace fairly quickly. Okay, now I guess there's some questions coming in. I haven't looked, but now would be a good time for a short break if anyone did have questions. I don't see any in the Q&A.
Yeah, thank you, Ed. Yeah, there is, I mean, there were a couple of questions, also interest in where a link to the registration page, which we have shared by now. I don't see any immediate questions. I mean, please type in questions if you have additional ones. But we can also take them basically towards the end of your demonstration, whatever comes still in. And yeah, let's maybe do it that way. So if you're ready to proceed, I would suggest do so.
Sure. Okay. So I move into the second workspace that we've developed. This is more what we would call, we've chosen two models here, and they've submitted multiple scenarios. This is what we would call, let's say, a two-model kind of comparison. And these two models are focused primarily on the EU region. So they have more granular data for EU countries, one by the Joint Research Center from the European Commission, and the other one from the Remind modeling team at the Potsdam Institute for Climate Change Research. I've set up a similar configuration. This model only goes to 2050, and we compare some of the variables, and we can see the reductions. We have not only, let's say, scenarios that are aiming to reach net zero in the near term, but also things that are more along the lines of current policy scenarios. But at the bottom here, we've configured a panel that only has one of these scenarios, but we've decided to include 8 of the final energy variables. So I selected the energy carriers for final energy. And that's a better example of how we can use the bar chart by clicking this button here. We can either see it in comparison to each other, or we can click this button to make it into a stacked bar chart. This is also a good example to show the documentation feature. So this button here gives us a panel. I mean, it just kind of overlays into the documentation that's available for these specific scenarios. So we can see that we have one model included. We can click on that, and there's a fairly brief description about the model and a link to the model documentation. It tells us what's the regional coverage. They've also provided nice information about the different scenarios. So a little bit about the narrative and what are the targets, and a link to the literature again and where it was published. We click on variable. This is the variable, and we see the definition and the unit. We can search this documentation quite easily also. Lastly, we move on, well, not quite lastly, but we move on to the aspect relating to how do we select and change different scenarios. And so that's we can access by clicking on the scenarios aspect. And this is normally the first bit. If we start a new panel, this is where we start from. We need to select the models and the scenarios. And there are primarily two different ways. If you know which scenarios you want and which models you're interested in, and this requires let's say some practice and also some expert knowledge sometimes, then we can browse them from the list, and we can easily filter by different types of models and scenarios. So if, for example, I'm interested in China, then we can see the variety of models that have China in the name. And this is something we try to do, is that all the country level models would have either the name or a 3-digit ISO code relating to that country in the model name, so we could find those national models easier. Or perhaps, for example, we were interested in SSP1, which is a sustainable pathway. We could filter all the scenarios that have SSP1 in their name. If we're in a more exploration, let's say, type of mood, or we don't know exactly what we're looking for, then we should use the category and the indicators selection. I'll just zoom in a bit. Primary, I think, category here for the selection in this case is what we call the regional scope. And so what kind of model scale are you looking for? Are we looking for global or national? So we can unselect, let's say, the global ones, just focus on what's nationally available. In this case, now we'll close these ones to demonstrate. So this will filter the list in terms of what are the national models that are available, and we can apply those selection changes, and then we'll have just those national scenarios. We can also, or we can go select, once we've made a selection, so we say we want just national scenarios, we go to select from list, we apply the category and indicator selection, and now we have just a list of the national scenarios. And we can select which ones we want, or we can select them all and click apply. Going back to the category and indicator selection, I just want to highlight some of the metadata indicators that can be also used to, in a more powerful way, filter and subset the data. So for people that are interested, for example, in particularly the global scenarios, then most relevant would be to filter by what we call the climate category. And so if you recall from the SPM table 2, a lot of the global scenarios were categorized according to their global warming outcome, C1 and to C8. They have different numbers of scenarios in those categories. That's these little numbers here. And we can select those scenarios. So I'm going to go into this drop-down list. I will select category name. Take a moment to load. And now we can see we can turn off and on the scenarios relating to, let's say, just the ones that are used there. Apply that, and we see that we have 1,202 scenarios. That's exactly the 1,202 scenarios that were used in table SPM2. If we just shows that C1 one, we'd get 97. We could also add some other ones that might be useful. So for example, CO2 emissions reductions. Another example here are the GHG emissions reductions, let's say 2019 to 2050. That relates exactly to this column here. And if we selected that option, this is not a categorical, but it's a quantitative filter. So it's numerical data. Takes a moment. We could then say, I'm interested in scenarios that only have GHG emissions reductions by 2050 between 50 and 60%. And then you would get a new selection of scenarios. You can apply those changes and we can filter. A few others that I would point out, because there's very many. We can select by the IMP marker, so just those 9 IMP scenarios, some global warming outcomes, some relating to which project the scenarios come from, or kind of scenario family, which sector, SSP family, and then also year of net zero 2 emissions, for example. So lots of information here. Takes a little bit of practice, but we've tried to make information that was also very specifically used in the report available for the selection of scenarios here in the database. There's even, for example, the option to filter the scenarios that Volker had showed in the figure SPM4. That was a slightly more refined set of scenarios. Lastly, we'll go on to building a new workspace. So I think hopefully I've introduced some of the key components of how to build a workspace, but to actually start with that is on the workspaces pages. Now we click the create the new workspace. And we just start by clicking a new time series panel and go from there. But the important feature, that I wanted to show about that is within edit workspace. So choose a name for your workspace, add a description. By default, it will be private and you need to save it. So you click this button here and that will get saved to the server inside your account. You can add it as unlisted, click the key. We get a unique share URL link and then you can copy it and share that to other people. And only the people that have the link will be able to see your workspace. This is good for kind of team collaboration, or the public option. And this is when you've got a really nice workspace, save it, and it will be available to anyone that logs into the AR6 Scenario Explorer. Lastly, there's also a feature to clone a workspace. And I'd reiterate that this is also a really useful feature. And so, for example, if we take one of those illustrative mitigation pathways, you can make edits on it, but you won't be able to save them. But you can clone that workspace into your account, make your own edits, and it's a great starting point, and then you can save them to your own account. Okay, onto the documentation. This is basically the full page that links to our documentation and metadatabase. And here we can see the full list of models that are included in the scenarios database. Some of them have more information than others. We tried to collect as much as we could, try to get the model teams to provide as much as possible. But there was, let's say, varying levels of information provided. But in almost every case, or majority of cases, we've provided a link to the model documentation. For the scenarios, there's very often a link to the published literature reference that we can see, and maybe the project that it comes from, if relevant. The variables, most of them have definitions about that variable, and that's useful because it takes some time to understand the variable structure, information about the regions, and then the metadata categories. So these are the categories that we could use to filter the database, and we can see what are the definitions or explanations of this of these metadata. So category name, this is the climate outcome from the climate assessment. See chapter 3 in Annex C. It's actually Annex 3 now. But definitions of these categories, if they're not self-explanatory. Onto the downloads page. So working in the Scenario Explorer can be a great way to start, but can also have some limitations, and maybe you just want to access the full data download. That is possible. There's a huge amount of data, I think more than 50 gigabytes of data that we collected in the end, and we've made these available as individual files here. So we're now on version 1.1 that introduced a little bit more data that wasn't published initially related to the climate assessment. And these data sets are split by the regional aggregation. So we have a file specifically for world, some for the different regional aggregations, and this ISO 3 one is for the different country, so the national level data. So if you're looking for European data specifically, you could explore it. I would recommend primarily in the R10 and the ISO 3 data sets. We have a data set about the metadata indicators, so this is useful for advancing kind of your filtering and analysis of the scenarios. And there's also some other data related to specifically what we called the climate assessment. There is a license for this data. It's an EU sui generis database license. It's based on a Creative Commons license, but it does have some restrictions. So if you are planning to use the data, let's say in a bit more public way, please do read the license. We very much want everyone to use the data as much as possible, but there are restrictions on how it does get, how it can be redistributed, let's say. And also, yeah, I think if you're using it and if you're publishing it, then please cite it. There's a huge amount of contributions to this. On the About page, lots of information about the scenarios process, how we collected the data, how it's used in the report, where different parts of the data are used in different parts. And I'd really encourage everyone to look at, in particular, also Annex 3, which is on the scenarios, modeling methods, and the database. We have some tutorial videos. There's information about the data releases, the climate assessment, which is its whole own project. And I think almost lastly, some acknowledgements. So none of this would have been possible without huge contributions from lots of lead authors across lots of chapters who assisted in collection of these data for global, national, and sectoral scenarios. Too many to mention, but ultimately led by Keiwan Riahi and also including Volker and Frank on this call, hosting the event, who coordinated this first national scenarios collection. Financial and institutional support from IIASA, Integrated Assessment Modeling Consortium, and also Horizon 2020 funding from the European Commission, supports database infrastructure and software team, essentially. And also encouragement support, a working agreement with the TSU from the IPCC, TG Data, great scientists like Ala, and also the Working Group 3 co-chairs. As I alluded in the video, this culmination of many years of work by many people in service of IPCC, bringing together and building on the work of hundreds of energy and climate scientists around the world. So really, bringing this all together. And during this assessment, the database supported the lead authors. I would say I'm proud to say that the process we organized has radically increased participation and the diversity of model scenarios available to the IPCC for assessment, and we hope this continues in the future. And after the release of the report, the database should transparently support the findings of the assessment, but it doesn't stop with the assessment. Now it's over to you that are watching in this webinar and further wider. So researchers, analysts, policymakers, the aim and the hope is that this is a useful resource in your day-to-day work, accelerating action on climate change. After the session, we'll share the recording and the detailed instructions. I hope you find it useful. Be first to say that working with scenarios data is messy and it's also complex. The website isn't perfect, but we tried our hardest. And if you have difficulties or questions, get in touch. And also if you've been using the data in interesting ways, we'd be really interested to hear from you. Thanks, Volker.
Yeah, thanks a lot, Ed, for this comprehensive overview. I think you've, in the meantime, also answered some of the questions that have come up. But yeah, the Q&A functionality has been quite active over the last few minutes. So there are a number of topics that I think we should go into. I mean, there was a couple of questions relating to documentation. I think you've basically answered those by the more detailed documentation feature demonstration that you showed. But yeah, let's go through first of all the open questions that we still have. The first one being by Laurie Puig. Where can we find the legend for category subsets, IMP marker scenarios, etc.? I think there are a couple of entry points here. I think you are probably in the best position to answer this.
Not sure I understand what's meant by legend.
Yeah,
as in how they're defined.
Yeah, I mean, I would see two possibilities to highlight here. On the one hand, there is basically the metadata filtering, right? Selecting the IMP categories, and maybe you want in the documentation, I think there's also IMP metadata definitions, which might be the right entry points here.
Right, yeah. So there would be some of that information would be in this file, metadata indicators. And otherwise, let me see, doesn't provide so much information there. I mean, the IMPs are described within the reports. I mean, we can provide more information there. A lot of this is primarily in the SPM. There's a box on the scenarios, and I think this is where the main definitions are.
Right, yeah. Thank you, Ed. And let's move to the second question. Okay, do you want to still go to the marker section, or
let me see if I find it?
Yeah, and then there is then maybe let me pick another question that I think Frank can answer. There is a question by Yuri Poroshenko. Are scenarios available for each mitigation measure and by country, let's say for bioenergy, optimization of fertilizer application, etc., by country and globally? Frank, I think you are in a good position to come in on this one.
Thank you. At the global level, so global scenarios, I think there have been quite a lot of mitigation measures, different types of mitigations that have been explored. I would not say that this is comprehensive, but I suspect that in the scenarios looking really at the global level, you will have a very wide range of mitigation options that is already in there. At the national level, if you're looking for information for a specific country, then the situation is very different. It will be very different across countries. In some, you have many modeling teams that have national models and that have produced a lot of scenarios, have used this model already to produce a lot of scenarios. That's true for China, it's true for the US, let's say true for the EU as a whole. But there are other cases where you have fewer models that have been used to produce fewer scenarios. So the range of mitigation options that is explored is not necessarily as wide as what could be as what is possible in a particular country. And so it really depends on which country you're looking at. Thanks.
Thank you, Frank. Ed, you wanted to still come in with the SPM on the IMPs, or? Because we're
I
still
actually responded in the chat. I mean, I think the information that they're looking for is in this SPM box, but if not, perhaps they could respond or send me an email, and I'll help them.
Okay, thanks a lot, because you're still sharing a screen with the SPM. We have next a question by Christopher Banefo. We have good data on emissions. We'd like to see what we'd like to see is equivalent data on carbon sequestration in the categories of terrestrial and marine carbon sinks. Where can we find this data? Let me first come in here. I think there is, in part, when we're talking about scenarios, a bit confusion between climate scenarios as coming of the global Earth systems and general circulation models. So basically on the evolution of the climate, where obviously the carbon cycle plays an important role, and there are also terrestrial and marine sinks important. This data is, I would say, comes in here via the link of the emission scenarios to so-called simple climate models. And maybe you can talk a little bit, Ed, can explain a little bit how the climate assessment and the linkage there, therefore, to Working Group 1 actually worked in the AR6. And the other point where we could maybe look, demonstrate where sequestration data is actually available in the scenarios is that some of the scenarios make usage of so-callald carbon dioxide removal, or CDR options. So basically engineered carbon removal via bioenergy with CCS, direct air capture, afforestation and reforestation measures. And those this type of data is, of course, also part of the Scenarios Explorer. Ed, do you want to come in on the one hand on the climate assessment pipeline, briefly explaining how that worked? So bringing that in, and then also maybe the sequestration data.
Sure. Yeah. So one of the collaborations and also a big innovation in AR6 was the linkage with Working Group 3 and Working Group 1. So the mitigation pathways here that produce emissions, but also measure carbon sequestration, need to be run through climate models of Working Group 1, but these are huge supercomputer, far too computational to do at the scale that we need to do it. And what we use is called climate model emulators. And this is a subset of simplified, but fairly complex also, climate models that do measure and represent the key interactions, for example, between these type of, let's say, terrestrial and marine carbon sinks and fluxes from the atmosphere up and down. And so whilst they are taken into account, we run the emission scenarios through these simplified climate models and emulate the supercomputer climate models used in Working Group 1 so that we know what the temperature outcomes are. We don't have the detailed information on that. That's really something for Working Group 1 report and databases. And in terms of the carbon sequestration, I mean, there's a wide range of scenarios within the database with both high and lower levels of carbon sequestration, both, that would say, anthropogenic in the sense from kind of carbon capture and storage attached to power plants, but also carbon dioxide removal mechanisms such as from afforestation. Yeah. Anything you want to add, Volker? Or
no, I think that's probably a comprehensive description. Next question I see from Colleen Poi. Is there an easy way to distinguish in the scenarios database between a national scenario produced by a national model and a national model that comes from the downscaling of a global scenario? I think here we actually, let me clarify, we haven't applied any downscaling. So but there is national level data, of course, also in global scenarios. Do you have recommendations on how to understand with the available data how far equity considerations were taken into account in the production of national scenarios? Do you want to start, and then I'm also happy to come in here.
Mm-hmm. Yeah. So if you worked directly with the data download and selected this ISO 3 data set, then that would include country level data that comes both from national level models and also global integrated assessment models. If you wanted to use the Scenario Explorer, then I would recommend keeping on that regional scope that I showed, keeping all of those options open, so global and national types of models, selecting the specific region or country that you're interested in, or countries that you're interested in, and then selecting the variables. I think that would be the way to do it, but it would be easier if done on a country by country basis. The main countries that tend to be available, this is not the full answer, but are the larger countries and the larger emitters: China, USA, India, Brazil, Russia, some of the European ones in general. Those ones are reported both by national and global integrated assessment models, depending on the model.
Yeah, thanks. And then I think Frank wanted to come in on the equity question. Frank?
Yeah, very briefly, I think that that's, unless I'm speaking under your control and Volker, but I think that's the equity dimension, or at least the intention of the modeler when he prepares a scenario. What he puts in may not be necessarily reflected into some of the quantitative variables that come out of the scenarios, but rather maybe in the title itself of the scenario, which may give a hint of what kind of policies, or what was the intent. For instance, you put a scenario where you put mitigation with a carbon tax and a lot of redistribution of the proceeds from the carbon tax. That would be a scenario where you try to take into account equity issues, but that would not, again, it's not in the quantitative figures that you will see it, but rather in the description of the scenario itself. However, I'm not sure that this is something that is easy to read for all the scenarios, and you may need to go back to the original documentation that Ed was referring to try and understand what was the context and the intent of the scenario itself.
Yeah, thank you, Frank. I think this is a very important point. Within the scenario data set, many scenarios, and this specifically refers to the global ones, take basically a cost-effectiveness approach in terms of effort sharing. That means mitigation happens where it is cheapest, without implying explicitly that the measures taken in one region or country need to necessarily be paid by that country. There is scenarios that make additional basically effort sharing assumptions based on a varying number of equity principles, for instance, converging towards equal per capita emissions at some point, or ability to pay, so taking the economic economic state of development into account or various other responsibility-based measures. One needs to be very careful, and here I can only stress what Frank has said. Is very dangerous to take this scenario ensemble as a quasi-statistical representation of a data set and draw conclusions from that. So if you want to really dive into a specific dimension to do analysis, there is really the need to go into the literature and in some cases go back to the publication on an individual scenario or on an individual scenario into comparison and look at what were the assumptions made, what was the objective of the study, to really understand whether that set of scenarios is suitable for answering the question at hand. So that is really an important one. I hope this is useful. We have another question on the documentation. It says for the János Hidi mentioning for the IEA Energy Technology Perspectives model, it says no additional information available. I guess that is something that we tried collecting this information from the producers of the scenarios. Not everybody in the end provided everything we were asking for, and there was limits in terms of being able to handle everything. Ed, you may want to add on this.
Yeah, I would just say, I mean, the scenario data is in the Explorer, but I think that message comes from about the documentation. So it's the description of the model and the scenarios that is missing from the organization, not that the data isn't in the database.
Right. Yeah, and that said, I mean, we've been trying to do as good a job as we could, but in the end, bringing these data sets together in the end ends up being a very daunting task, and not in all cases did we succeed in basically delivering a complete set, right? This is basically a side activity to improve or to generate the data set and allow the assessment and allow it to be used in the assessment. Right, I think we don't have any open questions at this point in time. Oh, there is one more. There is a question coming in from Görkem Günger. Can we include our data to the workspace for comparison? I think we had a similar question coming in elsewhere, whether the use of the Scenario Explorer for one's own data is possible. Ed, do you want to briefly come in on this?
Yeah, unfortunately not at this stage. And at least in this phase, in theory, this may be possible. I mean, it's technically possible in the future that, for example, in another IPCC assessment, modeling teams would upload their data and then you could see it and compare it with others. And effectively, the lead authors had access to this feature, but we can't make it. This is now a static database. This is what was in the AR6 report and what was submitted in the process. And we can't, unfortunately, add at the moment the possibility for users to add their own data and make the comparisons at the moment. But I can understand the desire. I'm afraid you have to take the data, download it, and do it yourself. Sorry.
Yeah. Thanks for clarifying this. There's another point by Natasha Frilingo. You mentioned earlier non-IAM scenarios. Non-IAM scenarios available. Is there an easy way to view those in the database? Now, not 100% sure how to interpret that. I think I mentioned in the presentation of on the NDCs and current policies, so the near-term policy assessment, that we use basically model data, and this is not always integrated assessment models. This, in some cases, also energy systems models that basically focus on the energy sector, emissions, sectoral models, and so on. But there's also other lines of evidence that are not necessarily model-based in an IAM or energy system model sense, that have, for instance, be used in the NDC assessment. Here, unfortunately, the answer is that that information hasn't been kind of combined into the Scenario Explorer infrastructure. But I think in this specific case, there is in the supplementary material of chapter 4 of the working group 3 AR6, there's some documentation on where that data is coming from. Then I'm afraid the question about how serious the world community is to restrict to the 1.5 degrees Celsius goal, we are probably not in the position to answer that. I think we are all hoping our best and trying to inform the discussion and the discourse about this as good as we can with the underlying report. And this is basically the objective of the IPCC, as I understand it. The decision-making is with others. Okay. Right. Is there, I mean, we don't have any open questions, and I mean, we are 1 hour 45 into the webinar. I would suggest we actually close without making this mandatory. I would just like to give at least the opportunity to the presenters and co-hosts of today's meeting to say a few words in case you still want to make a statement. Anyone wants to add to what already has been said? If there's no specific points, then let me thank everyone, including Frank for co-hosting and presenting, Ed for doing an amazing job on this demonstration of the Scenario Explorer, Ala for representing also the working group 3 TSU community and make a lot of things happen behind the scenes to have this to make this webinar work out. And there is, as earlier announced, there is going to be two upcoming webinars in about 3 weeks from now, on the 13th and 15th of February in Oceania, so in New Zealand and Australia respectively, and they will be followed by an additional set of meetings later on. We will also make, let me reiterate on that, we'll also make the material shared during this webinar available via the IPCC website so that it can be viewed afterwards. And Sebastian, let me also thank you for basically initiating the whole idea about organizing this webinar series from the TG Data side and contributing with the overall framing on the fair data principles and basically pushing the frontier within the IPCC there further. That said, let me also thank the audience for staying with us and asking a bunch of very engaging and interesting questions. So with that said, I guess we can close the meeting.